Hello, in this video I will continue initial value problems by plugging the given solution so that the left equals to the right. I will explain how to find your C1 or your constant 1 or constant 2. You might have two constants where you're given one initial value or two initial values. Finally, I will finish with an interval of existence and determine if a differential equation has a unique solution and determine the largest interval which the solution is defined. Okay, so we are continuing with initial value problems. So on the other video, I kind of did explain, we did some initial value problems before. This time, we're going to go more in depth. So any function f, which when substituted into an nth order or ODE or ordinary differential equation, reduce the equation to an identity is said to be an explicit solution. A general solution to be an nth order ODE is an n parameter in arbitrary constant C family of solutions. A solution of an ODE that is free of arbitrary constants is called a particular solution. Initial value problems are differential equations subject to constraint or initial value conditions. So what that basically means is you got to verify the solution by plugging in the given initial value, and if the left equals the right, then it's a solution. You might have to, and then we're going to have to find C1 or and C2 when given an initial value or two initial values. So steps to verify given function. So take necessary derivatives, right? Plug in the ODE. Simplify so that the left-hand side equals to the right-hand side. So you've done this before. Steps to find a solution to an IVP. So I think this is what you have to find. This is your constant. That's what you're trying to find. So plug in initial conditions into the ODE and its derivative to find the unknown arbitrary constraints. So yeah, this is where you have to find the C1 or C2. And then plug in the constraints into the functions. So let's do an example to see what we're doing. So example 1 says find the values of m so that y equals e raised to mx is a solution of y prime plus 2y equals 0. So it looks like we need to find m, and it looks like we got to find y prime first, because we have a y prime plus 2y. We already have the y, so we're good. So let's find that. So we're trying to find m. So first we got to find y prime. So what is y prime? Y prime, if y equals e to the mx, how do you take the derivative of power of e to a power? It's basically e to its power. So our power is mx. Leave that alone. Times the derivative of the power. What's the derivative of mx? Keep in mind, m is like a constant. It's just m, right? So y prime is going to be m e to the mx. Okay, let me box this. I'm going to have to plug it in soon. Okay, now I think we could put it into our differential equation. So y prime is m e to the mx plus 2 times y. Our y is e to the mx, right? Equals to 0. Now, can we clean this up? So we have m e to the mx plus 2 e to the mx equals 0. What to do next? We want to go, our goal is to solve for m. So is there anything we can take out, factor? Yes, they both have an e to the mx, so take that out. So this is going to be m plus 2 equals 0, right? Then if you set each equation to 0, so e to the mx 0, and then the other equation is m plus 2, 0, right? if we solve for m, this would give us m equals -2. Okay, now over here, how would you solve for m? You would have to get rid of the e. And how would you get rid of the e? By taking the ln of both sides, right? But you have a problem. So this cancels, so you're left with mx. And then what is ln of 0? That's undefined, right? And so this does not work. So you can forget about this. And also, what is the reason why it doesn't work is because if you graph it, it's an exponential graph, right? You have a horizontal, so an increasing exponential graph has a y-intercept of 0, 1, and yeah, you have a horizontal asymptote at y equals 0. So this will never work, right? So that is why this is our only solution. So our m value is -2. Okay, so that we did that one. Now let's move on to example 2. Okay, so example 2 says verify the given function is the general solution of the given ODE. So we have y equals c1 times x to the -1 plus c2x plus c3x times ln of x plus 4x squared. And we got to make sure we're just practically making sure the left equals to the right. That's it. So don't be freaked out about d cubed over dy. That's the same thing as third derivative, right? This is y double triple prime. D square y over dx squared, that's the same thing as y double prime. And then dy dx is the same thing as y prime. So don't be confused. I forgot what form that's like Leibniz form, but yeah, or implicit form. So this is third derivative, this is second derivative, and this is first derivative. So we have y. So if ry is c1 x to the -1, right? If that's our c1, I mean our not c1, our y, what would be our y prime, our triple prime, our double prime, and our triple prime? So we're gonna have to do some algebra. So let's first find y prime. So there's exactly 1, 2, 3. There's a total of 4 terms, and we just take the derivative of each term, right? So let's start with the first term. What's the derivative of c1 x to the -1? You just simply apply power rule, right? So -1 times c1 is -c1x, and then it's old power minus 1, so -1 minus 1 is -2. Okay, and then what's the derivative of the second term? Excuse me, c2x. You just apply the power rule, so this would just be c2. And then what's the derivative of the third term? So you have x times ln of x. You just have to apply the power rule, right? The product rule. So let's apply the product rule. So first figure out your f and your g. So wait, product rule is, if you recall, is f prime of g plus g prime of f. So first figure out your f and your g. So your f is x, your f prime is 1, your g is ln of x, your g prime is 1 over x. So it's going to be c3. F prime is 1. Regular g is ln of x plus g prime is 1 over x times regular f, which is x. So if you kind of clean this up, this is C3, 1 times ln of x is ln of x. 1 over x times x is just 1. So if you kind of boil out the C3, this would be C3 ln of x plus C3. Okay, so the derivative of this third term is C3 ln of x plus C3. Okay, last term, what's the derivative of 4x squared? That would be 8x to the 1. So your y prime, or you could also call it dy dx. Oops, sorry. Just making sure I have enough space. So my y prime, or my first derivative, or in our case, dy dx, is negative c1 x to the negative 2 plus c2 plus c3 . Wait, so plus c2, oh, plus c3 ln of x plus c3 plus 8x. Okay. Perfect. Okay, I wouldn't combine, do you see the C3? I wouldn't combine the C3 with ln of x. It just seems just more work than I have to. So I'm gonna, this is not our answer. I'm just gonna box it because we're gonna need that to plug it in, right? So the next thing we have to do is find y double prime. So again, how do we do this? So it's going to be d squared dy over dx squared, right? So just take the derivative of each term. So what's the derivative of the first term? That would be power rule. So negative 2 times negative 1 is positive 2 c1x. And then old power minus 1. So negative 2 minus 1 is negative 3. What's the derivative of c2? That's easy, right? c2 is a constant, so 0. The derivative of c3 is a constant, so that would be 0. What's the derivative of c3 times ln of x? So a constant times ln x. Well, I know that the derivative of ln of x is 1 over x, and then bring down the c3. Okay, and then the derivative of this additional c3 is 0, and then the derivative of 8x is 8. If I kind of clean it up, it would be 2c1 x to the negative 3. And then 1 over x is the same thing as x to the negative 1. So that would be c3 x to the negative 1 plus 8. Okay, so that would be my second derivative. And then let's gotta find our third derivative. So just like last time, take the derivative of each term. There's only 3 terms now. So what's the derivative of the first term? 2c1x to the negative 3. 2c1 is a constant, so negative 3 times 2c1 is negative 6 c1x, and then old power minus 1, so that's negative 4. What is the derivative of c3x to the negative 1? Negative 1, c3 is a constant, so power rule, negative 1 times c3 is negative c3x, and then old power minus 1, negative 2. And then what's the derivative of constant? 0, right? Okay, I'm going to kind of box it because I'm going to still need it. So now we have our first, second, and third derivative. Now we got to verify, right? So if you recall, our problem was x3 d cubed dy plus 2x squared d squared 1. What is it? It was minus x dy dx. Okay. Plus y equals to 12x squared. So let's see if this is true. So it's x cubed times d cubed. Third derivative is this one. So plug that in. So it's negative 6 c1 x to the negative 4 minus c3 x to the negative 2, right? So that's my third derivative. So it's plus 2x squared, and then second derivative is that one. So put that in. So it's 2c1 x to the negative 3 plus c3 x to the negative 1 plus 8. And then it's minus x dx, so here, minus x. And then first derivative was that whole thing, x. Okay, so I'm gonna need more space, so let's see if I can move more to the right. Okay, so I'm just gonna replace my dy dx with first derivative, so that would be minus c1 x to the negative 2 plus c2 plus c3 plus c3 ln of x plus 8x. And then plus y, so we know that y was our original. What was our y? Our y was the given c1x to the negative 1 plus c2x plus c3x ln x squared. Okay, so plug that in. Okay, so it's plus y, which is plus y is c1 x to the negative 1 plus c2x. That's not hold on. Okay, so where was I? Okay, so it's, and then plus c3x ln of x plus 4x squared equals to 12x squared. Okay, now we just got to do some algebra. Okay, so let's start cleaning this up. So boil this out. This would be negative 6 c1 x to the negative 1 minus c3x plus 4c1 x to the negative 1 plus 2c3 x plus 16 x squared plus C1 x to the negative 1 minus C2x minus C3x minus C3x ln of x minus 8x squared plus C1 x to the negative 1 plus C2x plus C3x ln of x plus 4x squared equals 12x squared. Okay, so if you do the algebra, what the fun part is canceling as much as you can. So you can box, you can circle C1x to the negative 1, box anything that has a C. So this is a negative C1. This is a 4C1 x negative 1. This would be C1 x to the negative 1. C1 x1. So basically, if you do all the algebra, I'm not going to do it, but you can go ahead and pause. Everything cancels except, so on the left side, you're left with 12x squared. And then on the right side, you're left with 12x squared. So if you do all the algebra, can look like terms, everything cancels. And then now you're left with 12x squared equals 12x squared. Okay, so we just verified, and then you could just put a check mark. That means verification. Okay, that was kind of like the long one. Just need your, you need to know how to do your derivatives. Okay, let's move on. Example 3 says, use the fact that y equals 1 over 1 plus c1e to the negative x is a one parameter family of solutions of y prime equals y minus y squared. To find the solution of the interval initial value problem, y of negative 1 equals 2. So what we're trying to do is basically find your constant, right? C1. We have a C1 in our problem. We don't know what it is. That's what we're going to find. And then what we have is a initial value or a coordinate. Y of negative 1 is the same thing as negative 1 comma 2. And then we have the derivative. Okay, so what would I do? What I would do is do not take the first derivative. What would I do? I know. I would use this equation and plug in my initial value. So I would plug in my y value and plug in my x value. That's what I would do. So my y value is 2. So it's going to be 2 equals 1 over, and then it's going to be 1 plus C1e. And then what's my x value? It is negative 2. I mean, negative 1. So what's negative times a negative 1? Positive 1. Okay, and then I guess you can cross multiply. So what's 2 times this whole thing? I'm just going to write it out. 2 times this whole thing is 1 plus C1e to the 1 equals, and then what's 1 times 1? 1. Clean this up a bit. So or FOIL it out. 2 times 1 is 2 plus 2C1e to the 1 equals 1. I guess you could divide everything by 2. Your goal is to solve for C1, right? Divide everything by 2. This is 1 plus C1e to the 1 equals 1/2. And then what I would do next is get rid of the e. So how would I get rid of the E is, oh no, get rid of the 1. So I would subtract 1, subtract 1. Let's cancel. So you're left with C1 e to the 1. And then this is 1/2 minus 1, or 2/2. So that would be C1 e to the 1. And then what's 1/2 minus 2/1? That's negative 1/2. Okay, and then what would I do next is find C1. So you would have to divide, you can divide E, or you can multiply both sides by 1/E. So this is C1 equals to negative 1/2 2E. I'm going to box it. So we found our C1. Now we got to plug it back into your original equation. So your original is this one. So it's plugging the C value into your original equation. So it's going to be y equals 1 over 1 plus my C value, which is this. So it's going to be negative 1/2 2E times e to the negative x. So you can simplify these negative 1/2 e over e to the negative 1. That would be so what is, just boil that out. So that would be negative 1/2 e to the negative x over e to the 1. So remember, when you're dividing with the same base, you subtract the powers. So this e to the negative x over e to the 1 is the same thing as e to the negative x minus 1. So this is going to be minus 1/2 e, and then the negative x minus 1. Okay, so if you want to clean this up, it would be y equals 1 over 1 plus a minus, that's really minus 1/2 e to the negative x minus 1. Okay, so that is your final answer. Okay, so let's move on. Let's do example 4. So this time, so example 4 states, use the fact that y equals C1 e to the x plus C2 e to the negative x is a 2-parameter family of solutions of y double prime minus y equals 0. Find the solution of your initial value problem of y of negative 1 equals 5, y prime of negative 1 equals to negative 5. So this time we got to find C1 and C2. And it looks like we're going to have to do system of equations. So what would I do first? I would plug in this initial value first. So this would be negative 1 comma 5, right? It's my initial value. Okay, so what I would do is plug that back into your original equation. Y equals C1 e to the x plus C2 e to the negative x, right? And I'm going to plug that into this equation. So I'm going to plug in this coordinate into this equation. So my y, you can replace your y with 5. And C1 e, and our x value is negative 1 plus C2 e. And then it's my e raised to the negative x. So it's a minus, that's positive 1. Okay, I'm going to kind of box it because in order to find C1, C2, we're going to have to do a system of equation. We'll have to do elimination. Okay, and then our other coordinate, I'm going to plug in this other coordinate. This is like negative 1 comma negative 5. And to the, I'm going to put it, Since this is first derivative, I gotta first find my first derivative, right? Right? If this is first, if your other second condition has a y prime, we're gonna have to find first derivative or y prime. So here's our y prime is not too bad. So what's the derivative of c1 ex? It's just itself, c1 e to the x, right? What's the derivative of the second term, c2 e to the negative x? Well, don't worry about the c2 is a constant, so bring it down. Just worry about e to the negative x. What's the derivative of e raised to the negative x? It's e to the negative x times the derivative of the power, which is -1. So y prime is going to be c1 e to the x, and then -1 times c2 is negative c2 e to the negative x, right? Okay, then what I'm going to do is plug in my second condition, right? So I'm going to replace my y prime with -5, and I'm going to replace my x with -1. So e to the negative times the -1 is +1. Okay, and I'm just going to box it because I'm going to use it. Now I can set up my system equation. So here's my two equation. I'm going to set it up. So I'm going to set it up. I'm going to put the constant to the right. So it's good. So with this equation, I'm going to put the constant to the right. So I'm going to rewrite it as c1 e to the -1 plus c2 e to the 1 equals 5. And then I'm going to set the second equation as c1 e to the -1 minus c2 e to the 1 equals -5, right? I'm going to do elimination system, and what can I do? I think I just have to add them up vertically, right? I don't have to multiply. If I add them up vertically, something will cancel. Yes, the C2s will cancel, so that's good. So vertically, so what's C1 e to the -1 plus C1 e to the -1? You can add them up because they're both to the e to the -1 and they both have C1. That would be 2C1 e to the -1, and then this cancels, equals, and then what's 5 plus -5? 0. And go ahead and try to solve for C1. So what would I do next is get rid of the constants. So your constants are 2 and e to the -1. So get rid of them. Let's get rid of the 2 first. So I'll divide both sides by 2. Now you're left with c1 e to the -1. And then 0 divided by 2 is 0. And then e to the -1 is a constant, so you can get rid of it by dividing both sides by e to the -1. So I get c1 equals to 0. Okay. Now what we have to do is find c2. And I'm going to substitute, so I'm going to do substitution. I'm going to substitute my c1 into the, I'll plug it back into the first equation. It doesn't matter which one as long as it's an original. So my c1 is 0, so it's going to be 0 times e to the -1 plus c2 e to the 1 equals 5. So what's 0 times e to the -1? That's 0. And then now you're just left with c2 e to the 1 equals 5. And then just solve for c2. So get rid of this e by dividing both sides e. So c2 is 5 over e to the 1. Okay, I'm going to box it because now what I'm going to do is plug these two constants. So now we found our c1 and c2 by plugging it into the original equation. So our original equation was y equals c1 e to the x plus c2 e to the -x, right? So my c1 is 0, so it's going to be y equals c1 is 0 e to the x plus c2 is 5 over e to the negative x. So this cancels, so you're just left with y equals, and then you can rewrite this as 5e to the negative x over e to the 1. So remember, when you're dividing with the same base, you really subtract the power. So this thing right here could be expressed as e to the negative x, and then we're dividing, so it's really subtracting, so it's minus 1. So you're just left with this. So you're left with 5e, and then it would be negative x minus 1. Okay. Okay. Let's do one more example, and then we'll do interval of existence in another video. Okay, example 5. Use the fact that x equals c1 times cosine of t plus c2 times sine of t is a two-parameter family of solutions of x double prime plus x equals 0. To find the solution, you're given the initial value of x of pi over 2 equals 0, and then x prime of pi over 2 equals 1. If x equals c1 times cosine t plus c2 sine t, and yeah, your initial value is pi half over 2, and then x prime is this. Okay. Oh, I kind of did. I did one extra step. So this is just like the previous problem. So this is initial value. So this is like a coordinate pi half comma 0. And then this is going to be pi half comma 1, right? So what I will do is, this is what we have. Okay, so I kind of went one step ahead. I found x prime. So it's pretty simple. You just take the derivative of each term. So what's the derivative of c1 cosine t? Well, c1's a constant. So the derivative of cosine t is negative sine t. So that's how I got negative c1 sine t. And what is the derivative of c2 sine of t? C2 is a constant. The derivative of sine t is positive cosine t, right? Okay, now what do I do next? I plug in my initial value. So let's plug in this initial value. Pi half is your x, 0 is your y. So you're going to replace this x with, like, it's like your y value. So it's 0, and then it's c1, and then cosine of t. So my x value is pi halves plus c2 sine of pi halves. But 0 equals c1, and then what's the cosine of pi half? 0 plus c2, and then what's the sine of pi halves? 1, right? It's 0 equals c1 times 0 is 0, plus c2 times 1 is just c2. Okay, then I'm gonna plug in. So I'm gonna use my x prime, and I'm gonna plug in this value. Pi half your x, 1 is like your y. So replace x prime with 1, and then it's negative c1 times sine. Replace your t, their x coordinate, which is pi halves. What is the sine of pi half? It's positive 1, so that's negative c1. What is the cosine of pi halves? Is 0. So 1 equals negative 1 equals negative 6 c1 is, well, this cancels, so get rid of the minus, so divide both sides by negative 1. So c1 equals to negative 1. Okay, so we found our two constraints. Our c2 is 0, and then our c1 is negative 1. And then you just plug it back into your original problem. So your original problem was x equals c1 cosine t plus c2 sine t. So x is -1 cosine of t plus c2, which is, I guess we could say c2 is 0 times sine t, right? So this cancels, and then now you're left with x equals negative cosine of t, right? Okay, so that is your final answer. This one right here. Okay, now we'll do, on the next video, we'll do interval of existence. So I'm going to stop here.